to shift gears a little bit and learn how to graph rational functions. So we're going to be doing something different. A lot of people really like these because it's not really hard advanced math thinking, it's just knowing how to do it. So it'll be nice, a nice relief, but you have to pay attention to little details of what we're learning today. So rational functions, guys, we're learning how to graph them today. We'll be dealing with rationals the rest of the year in this class. In secondary 3, it's one of the big things. So today, after this class, you'll know how to graph a rational function. So what rational means, guys, is fraction. So every time you see the word rational, just know it means fraction of some sort. So rational functions are functions that have a x in the fraction, in the denominator of the fraction. So right here, f of x is equal to 1 over x. Notice this is a function with x in the denominator of the fraction. That's what makes it a rational function. It's a fraction, but x is in the denominator of the fraction. So if the x was above and there wasn't an x in the bottom, it wouldn't be considered rational. All right. All right, so this is where you want to write down a few key things. So notice a few key things about these rational functions. So the parent function, guys, you're going to see this word a lot this year. Parent function just means the most basic, non-shifted graph. So the beginning, just like the parents were the beginning to you, parent functions are the beginning to their children functions. So I made up the children function part, but we're going to take these parent functions and we're going to shift them and move them around, okay? So parent functions have no shift. So looking at this is the parent function for a rational function. F of x is equal to 1 over x. Now, this is what the graph looks like, and this is what you're going to have to know before we can graph shifted functions. So look over here with me at the graph of a rational function. It has asymptotes at x is equal to 0. So x is equal to 0, and y is equal to 0. So if you look at this, this is y is equal to 0, and this is x is equal to 0. There's asymptotes at those places. Now asymptotes, yes. Yeah, that's what I'm going to explain right now. So an asymptote is a value, a place that your function gets really close to but never crosses. So I'm going to say that again. An asymptote is something your function gets really close to, but it never ever crosses it. Now notice some other key things about these rational functions. Notice it starts up here on the right-hand side, and it curves around, comes down really close to the asymptote. Doesn't ever cross it though, it can't cross the asymptote. Now if I grab that and folded it across the diagonal, kind of like a sandwich, but across the diagonal, then we would see it over on this side as well. Now notice my function's getting really close to the asymptote, it doesn't cross it, and it's coming down here getting really close to the asymptote, but never crossing it. Okay, any questions on that? You just have to know what it looks like, and then you can know when we're shifting what we're going to do. Okay, so now we're going to take this parent function and we're going to shift it. So shifted functions have this form. So you'll want to write this down. Here we go. We're going to take the parent function and we're going to shift it. So it's going to have this form. F of x is equal to 1 over x minus h. There's no longer just x, it's x minus h. And then we have our plus k. So before I get into what those things are, I just want to point out a few key things here. The x minus h is underneath the fraction, and the h stands for like horizon. That's our shift on the x-axis, on the horizon. And then the plus k, notice the plus k is out here added on the outside of the fraction. So it's not added under here with it. It's on the outside here. It's added to the whole function here. Okay, so now when you look at these, you'll look underneath first and you'll say, okay, what's my shift on the horizon? So that's our shift left and right. I'm never going to say horizon. I'm going to say, what's our shift left and right? Well, you can tell that from what's under here. And so we have x minus h. We know it's going to shift minus h. And you always go, it's going to shift x minus h, and it always goes the opposite of the sign. That's the important part. It's always going to go opposite of the sign. You'll see what I mean in a second. Then the plus k, that's our shift on the y-axis. This is our shift up and down. And the sign stays the same. So you'll have to go with the sign on this one. Now guys, the cool thing is the rest of the year we're going to be taking functions and shifting them. The rules work every single time we shift a function. The rules are going to be the same. opposite, anything added on the outside is going to shift the same. Okay, so opposite, the same. Very, very important. Now, yes, you're still kind of like, I don't get what you're saying here. You're not going to get it till you see it. So let's do our first example here. Does everybody have this written down? This is our shift left and right. You always go the opposite. This is our shift up and down, and it's going to stay the same. Does everybody have that written down? All right. Am I okay to move on? I'm asking. Okay. Okay, so then before we actually, the last thing we have to look at here, before we actually start doing this, we do need to take into consideration one more thing with rational functions. So notice in this function, f of x is equal to 1 over x minus h plus k. Notice in front here, there's not a negative sign. There's not a positive sign either, but it goes without being said that that's positive, right? If there's nothing written out front, it's a positive. So what you'll know is your functions will start at the top right. So look, I've even color-coded this for you. In yellow, look with your eyes over at, we know rational functions look like this. So since this one's positive, it's going to start in the top right. So does everybody see how I even color-coordinated it? It's starting in the top right, up here in this vicinity, okay? And then we just fold it over the diagonal like a sandwich, and we know it's going to be down there. So this just tells you where your function starts. Then let's go down here. I color coordinated it for you. If you're given f of x is equal to negative 1 over x minus h plus k, that negative in front just simply says, okay, your function's going to still start at the top, but now it's going to start on the left. So negative is left. So we're going to start on the top left. So look up here. Now instead of starting at top right, it's starting at the top left. And once again, it folds over like a sandwich, so we know it's going to be down here. So now we know how to graph these functions. As long as you know the shifts, that'll be our first thing. We say, what's the shift? And then we say, where does it start? Top left or top right? And it all depends on if it's a positive or negative. So negative is left, top left. Then it's easy. It folds like a sandwich across the diagonal. And if it's positive, it's top right. And then you fold it like a sandwich across the diagonal. Now, hopefully, ask questions in a minute when we start practicing these, because it's not going to probably make complete sense. You're not going to know exactly what's happening until you see it. So let's just go through and you tell me what are the shifts on these graphs. So these are the steps. I've already talked to you about the steps a little bit. So first of all, when we're graphing these, we'll say what's our shift left and right? What's our shift up and down? So we're determining the shifts first, and then we're going to draw in our asymptotes. So our asymptotes, interesting fact, everybody listen, our asymptotes are going to go where our shift goes. So they were at 0, 0 in the parent function. We're going to take it, our function, and shift it a certain way, and your asymptotes are going to be drawn at the shifts. So if you need to write that, so asymptotes will be drawn at the shifts. So will be at shifts. I couldn't fit the at, so I just skipped it. So an asymptote will be at your shifts. Once you've drawn in your asymptotes, you'll ask yourself, does it start in the top right or top left? So then you look in front and you see, okay, it's positive. So I'm starting at the top right, you draw it in. Or if it's negative in front, you draw it in the top left. And then the third thing is fold it on the diagonal like a sandwich and draw it in the second half. So really I'm giving you step-by-step instructions on how to graph these. Okay, let's practice it. So I'll give you another second to get those down, those steps down, and we'll practice. When I take you free to work, I'll come back to it. All right, so before we actually graph these, let's just practice what's our shifts, because that's really important. So looking at this one, I just want you to determine with me what's our shift left and right, what's our shift up and down. So you don't have to take notes during this part. It's going to be more beneficial for you to look and ask questions if you don't understand why we say the shift is what it is. So looking at this one, what's our shift left and right? Right 3. You always go the opposite of what's underneath. Does everybody understand why I decided to go right 3? It was x minus 3. That's a negative, so we're going to go opposite. So right 3. Okay? Now looking at this, what's our shift up and down? Does the sign stay the same? Yes, so we're going up 2. Do you have questions on why I decided that was my shift? Ask if you do. Other people do if you do. Okay, let's determine the shifts below. What's my shift on this function, left and right. Left or right? Left, okay, so it's left. What? Left 5. You always go the opposite of what the sign is underneath. Any questions on why we said left? It was positive, so we're going the opposite, which would be left. Left 5. And then what's our shift, up or down? Good. Our sign stays the same, so we'll be going down 3. Now, guys, these are where our new asymptotes would be. We would go right 3, and then there would be an asymptote at 3, and then we'd go up 2, and there'd be an asymptote at 2. So we'll practice drawing that later. Once again, we go left 5, and we draw an asymptote, and then we would go down 3 and draw an asymptote. Okay, a couple more. Tell me, what's my shift, left and right? Right 1. You always go the opposite. Very good. We're getting the hang of it. And then what's my shift? Down 1. Very good. Down 1. All right. So what's my shift here? Good. Left 2. Good. And then what's my shift up and down? Up 3. Okay. Good. Tricky one. Uh-oh. Tricky. What is my shift left and right? Nothing. There's not a 1 in there, right? No ones. So it's not going to be a 1. It's 0. So we're going to shift left and right 0 or just none. Either one. No shift left and right. Does everybody understand? There's no number added. There's technically a 0. So that'd be left and right 0. And then we're going left. Up 2. Very good. Continuing. Last one here. What's my shift left or right? Good. It's right 10. You always go the opposite of what's underneath here. So right 10. And then what's my shift up and down? None. There's nothing added, or technically 0. So we could say up / down 0. Very good. Questions? Okay, let's practice. Here we go. Here's the wham bam. Here we go. Okay, guys, first step. Everybody listen to me. First step, determine your shifts. First step, determine shifts. What's our shift left or right? Right 1. All right, and then what's our shift up and down?
Down 1.
Good, down 1. Very good. Okay. Now what you're going to do, guys, is you're going to draw in your asymptotes. Now this is very important to listen to me on this part. With asymptotes, you have to draw them as dotted lines. If you draw a line, I'll mark it wrong because asymptotes are not full lines. They're dotted lines that you know that they're asymptotes, which means a value that it gets really close to but never crosses. So let's go right 1 and draw an asymptote. So we're going right 1 and we're drawing an asymptote up and down. So at 1. So at the value 1, I'm drawing in my asymptote here. Oh, I can just look. Did everybody see how I drew in an asymptote with a dotted line? At right 1. Now we're going down 1 as well. We've got to draw in our asymptote. So from here, I'm going down 1, drawing in my asymptote as a dotted line. Any questions so far? Okay. All right, so now we've done our first step. The second step is decide. Second step, decide if it starts on the top right or top left. So remember to look at the sign in front here. We're looking at the sign in front. Is that a positive or negative? Positive. So we're starting at the top right. So now this is important to understand. We're going to use our asymptotes. Does everybody see how it looks like an X, Y chart? You're going to ignore the old XY chart. That's your new XY chart. Okay, you're going to look at that. And we know it starts at the top right. And we know these functions look like this. They're going to get really close to the asymptote, but they're never going to cross it. Does everybody see how I drew that? And now I'm going to fold it like a sandwich over the diagonal. So we're going to be right in this vicinity. Now we're going to get really close to those asymptotes, but never cross them. And I have a beautiful drawn function. Any questions? Okay, we're going to do a couple more, and then I'm going to let you work. Are you sure you don't have questions? Yes. What if the top number isn't 1? We're not going to see that today. Yeah, it does matter, but we're not going to see it today. Yeah, good question. So if this wasn't 1, yes, that would matter, but we're not going to see that in regular for now. Okay, good question. Love it. Moving on, let's do this one. Everybody stay with me, and I'm going to let you work for quite a long time, okay? So let's go through this really quick and determine our shifts left and right. So first step is determine your shifts left and right. Where am I going? Left 1, you always go the opposite. So left 1, and then where am I going? Down 3. Okay, awesome. I'm going to draw in my asymptotes at that. So I'm going left 1. I'm drawing in my asymptote here at left 1. And then I'm going down 3. So I'm going to go down 3 and draw in my asymptote. Do you have any questions? Yes. Oh yeah. I messed that one up. That's a typo. Put 1s there. Put 1s there. We're not. This was for my honors class. So yeah. But all of them put 1s. Yeah. Okay, good question. I didn't realize. I forgot that I had used this in my honors. Okay. Okay, so then we'll go on to our second step, which is to decide, does it start on the top left or top right? So you look in front. That's a negative. So are we starting top left or top right? Top left. Very good. So top left. So then I'm going to go ahead and draw it starting at the top left. I know it gets really close to those asymptotes, but never crosses. And then I fold it like a sandwich over the diagonal, so I know it's going to be in this vicinity. Never crossing those asymptotes, but getting really close. Okay, questions on that? Okay. Very good. Now, I need you to understand one thing before I set you free to work. If you're getting it, then I won't do this example. But this one I want to do, and then I'm going to set you free to work. So let's determine our shift left and right. Where's our shift left and right? None. So we're going left and right, none. So no shift left and right. So no left or right shift. Okay. Now what's our shift up or down? So up 5. Okay, let's draw in our asymptotes. There's still an asymptote at 0. When you do no shift left or right, you still have an asymptote at 0. Because technically you're shifting left and right 0. Does that make sense? If I don't see an asymptote on your test, you're wrong. Does everybody see how I drew an asymptote at left and right 0? And then at up 5, I'm going up to 5 and drawing in my asymptote at 5. Okay, now once again, let's continue. Is this going to be start at the top left or top right? Top left due to that negative, so top left. So then I go to the top left. Now look at my top left on this one's clear the heck up here because we're pretending like that x-axis is gone. We're looking at my asymptote. Don't come down here. It's up here. Top left is up here. This is my new origin. So top left would be up here. So that's my top left, and then I fold it like a sandwich over the diagonal. And it comes down like this. Does that make sense of how these work? Way easy. That's what I like to hear. Okay, practice the problems 1 through 8. Try it alone first, and then ask a neighbor. I need to see a few more examples here. So looking at something like this, if we were asked to solve for x, notice we have a lot going on the left side of the equation and a lot going on the right. So I'm going to go through and simplify this. We've already learned this. I'm going to go through and simplify this on the left first and on the right so that it's easier for myself. So we have to be careful. 2 is multiplied to x minus 2, x minus 3, because it's in parentheses here. So I'm going to distribute it through. So 2 times x is 2x. 2 times negative 3 is negative 6. Well, we can't forget about this minus 2, so we got to write that in. Questions on that? Okay, that's equal to, now I'm going to go over here on the right and simplify this side of the equation. All right, so this negative out here in front of these parentheses, we've got to be really careful with that because technically what we have here is negative 1 times all that stuff. So negative 1 times x is negative x. Negative 1 times positive 5 is negative 5. And then from here, I'm going to combine all like terms over here on the left. So I have 2x. Negative 6 minus 2 is negative 8. Don't make any errors here. Think about those really hard. And we have is equal to, we still have negative x minus 5. Do we have questions up to here? I'm just simplifying the left, simplifying the right. So now from here, guys, we can combine our like terms. So we have to move it from one side of the equation to the other using the correct operations. So I'm going to bring negative x over to this side. So make sure when you add x to both sides of the equation, you're adding it to both sides of the equation, not adding it to like this add 5. I saw people say add x, because they're thinking both terms. But we're doing it to both sides of the equation, not both terms. Plus, you can't even add a negative 5 with an x. Those aren't like terms. So I'm going to add x to both sides of the equation. Now over here on the left, 2x's plus 1x's is 3x's. So I have 3x's minus 8. Minus 8 is equal to, now check your work. That better have added up to be 0 or you've done something wrong. Negative x plus x is 0. So we took care of it, leaving us with just negative 5. The goal is to get x alone, so I'm going to add 8 to both sides. So then I have this so far. I'm going to give myself some more room. So I'm here. So over here, I have 3x. I'm going to check and make sure that adds up to be 0, and it does. 3x is equal to, and then 8 minus 5 is positive 3. Everybody? Then to get x alone, divide both sides by 3. It divides out to become 1. 1 times x is just x. So we have x is equal to 3 over 3 is 1. X is equal to 1. I solved the equation. So that's what you're doing on problems 1 on that second page. 1's A and B. Now everybody should quickly glance up here and, well, yeah, let's go through this one, and then I'll have you glance up here. So looking at this one, we have 5m minus a times 6m plus 3a. What throws people off on this one is that we have two different types of variables. So I'm going to just go through this one to make sure we're good. So I need to multiply all of this to all of this. So I'm going to focus on 5m first and distribute it through to each term. 5m times 6m is, and guess what? You got to be careful. 5m times 6m is 30m, and most of you put 30m. It's not 30m, it's 30m squared. Very good. 5m times 3a is positive 15am's. M times a, or a times n, is just ma, or am's. Questions on that? Okay, then distributing through negative a. So negative a times 6m is negative 6am's. And then we have negative a times positive 3a, and I'm going to be so careful here, and that's negative 3a squared. A times a, guys, is a squared. It was negative a squared, that made it negative 3a squared. Now here's what's important, and in secondary history I have to hold you to it. You are held to a higher standard. You have to write this in standard form, meaning the highest degree and then the next highest degree and the next. So first, before I do that, I'll hurry and combine like terms. So I have 30m squared. You can't combine that with a squared. It's different terms. So we have 15am's minus 6am's giving us, what is it? Yep, plus 9am's. am's. And then we have our minus 3a squared. So once again, I just combine those two things because they're like terms, am's. Now standard form, guys, if you stopped here, you would get it almost correct, and then you would have just barely missed it. You have to write it in standard form, meaning the highest degree, then the next highest degree. So 30m squared is one of the highest degrees, and my negative 3a squared is equally as large as 30m squared, because we only look at the degree. So if you wrote negative 3a squared first, that would be fine. But that has to come next. Negative 3a squared, and then plus 9am. Now technically, guys, this is degree 2 as well. because this is degree 1 and 1, so that's degree 2. So actually, this one would actually probably be okay in any form. But just, yeah. So actually, because this is degree 1 and this is degree 1, even though you can't add those, it's still considered degree 2. So in this one, you would have lucked out and been able to put them in any order. All right. This is the forbidden rule. Do not break the forbidden rule. And I guarantee 85% of you will. So look up here really quick. 6 minus 2y squared. This is what half of you will want to do. 6 squared minus 2y squared. That would be breaking the forbidden rule. You can't do that. You don't get the right answer. Promise. You can't do that. You can't just square 6 and square negative 2y. You have to rewrite this as 6 minus 2y times 6 minus 2y. And then you have to go through and double distribute. And then combine like terms. Okay? You won't get the same answer. 6 times 6 is 36. 6 times negative 2y is negative 12y. And I'm going to distribute negative 2y through. Negative 2y times 6 is negative 12y. And then negative 2y times negative 2y is positive 4y what? Squared. Very good. Now if you look at this, we can combine like terms. So we have 36. Negative 12y minus 12 more y's is how many y's? Negative 24 y's. And then plus 4y squared. Now if you stop here, I'd give you probably 2 out of 3 points on a test, for example. Because you didn't write it in standard form. This is not standard form. Standard form is the highest degree first to the lowest degree. So you got to be careful when rewriting this that you keep the signs with what they are. So this was positive 4y squared. It's got to stay positive. 4y squared. This is negative 24y, so it needs to stay negative. Negative 24y. And this was positive 36, so it needs to stay positive. So then plus 36. You would need to rewrite it in standard form. So this would be my final answer. Okay, that's my last example. You have the rest of the time to work. Do not put it away. Don't waste my time. Use it, clear till the end of the hour. So you have a full-on 25 minutes to be working on this and getting help and finishing up other assignments and then handing them in. Do not put anything away until you're finished. Okay, the time is yours.